Hello, welcome to my channel. This is Shakil Ahmed. In this tutorial, we will learn how to uh, evaluate the performance of different diagnostic tests, and then we can also learn how to find a cut point for a risk score to determine the outcome of a disease. Uh, that is when we have some exposure and some outcome variable, and we see what will be the cut point for the continuous exposure. For example, if we see that the um, blood pressure is related to the cardiovascular disease, then we can find a cut point for the blood pressure about that or below some threshold or about some threshold. We declare the person as having disease or not. So that is basically called the risk factor, and we find the cut point for certain risk factors in determining a outcome. So this is our target that is needed in diagnostic studies where we need we measure different biomarkers and we check the disease outcome of the patient, whether the patient has disease or not. That is decided on the basis of that cut point. And basically, we find the cut point by maximizing the uh, accuracy, how the risk factor is determining or predicting the outcome. So we have different measurements like sensitivity, specificity, and positive predictive value and negative predictive value. So you should have a concept about all these measures while applying these codes. So I will just show how we can find the area under the receiver operating characteristic curve and how we can find a cut point for a continuous variable in determining the outcome. So let's start with the hard data set. That is, I'm just I have just downloaded from Kaggle and already saved in my PC. You need ROCIT package. You need to install. This is available only for the updated versions of R. If you don't have updated version 4.3.3, uh, it will not work. So make sure you have installed an updated version of R. And we need ggplot for making receiver operating characteristic curve. And I have just written this package twice. Just remove and the package reader to read data from CSV. And then we see that the class is target basically whether a patient has heart disease or not. That is our main target variable that is called the outcome. And this is in already numeric. And if you uh, are working with logistic regression, then you need to change it to target target into factor as it reads the factor of basically the outcome should be affected. So let just run a logistic regression and we can find the class labels logistic model, and with y it means it will give the y predicted y values, and you can see different classes, and then we can see the uh, probability scores. Basically, the on the basis of the probabilities, we determine whether an outcome is 1 or 0. So we can find a threshold for the probabilities as well. Above what threshold we declare an event as one, and what on below that threshold we declare the value as zero. So we finding a threshold. So how we can find? We can find through a measure IT function as well, and this will give all types of measures, including overall accuracy of classification, how many classes are accurately predicted, and misclassification rate, that is number of classes misclassified, and sensitivity, that is true positive divided by total positive, and specificity, true positive divided by predicted positive, and uh, you can just make sure that the sensitivity and specificity are clearly defined. But you can find all these of precision and recall, and then positive predicted value, negative predicted value, and true positive rate, false positive rate, and true negative rate, false negative rate, and you can find the positive diagnostic likelihood ratio, and finally the F1 score. So I'm just just showing the results for ACC accuracy, sensitivity, and F1 score, that is written twice, I think once. So now we can run this function. This function will provide all the measures, and it will provide the cutoff for the probability for the score, and the depth, and true positive and false positive, and all these things. You can just run this command. I think you can write this summary as well. It will give all the values for all data set, basically for all data points. It's giving, and 94.94 is the cut point for probability. It means above this point we declare the value as 1, and below this point we declare the value as 0, and this is the depth, but you don't need to interpret this. And the true positive, this is number of true positive, this number of false positive, and this is uh, the true negative number of true negatives, and most of the cases are negative for this data point and for this threshold. And we have accuracy, and we have sensitivity, and we have uh, F1 score for a given threshold. So it starts from infinity and taking different values. So for different threshold, we have different measures of accuracy. So basically, we need to set a threshold with maximum value of the area under the curve. Or in other case, you can use Udan index in determining the cut point. For the cut point will be selected, which provide the maximum value of the Udan index. So we can plot this just accuracy versus cut point. So you can see for different cut points, we have different value of the accuracy. So measure of accuracy is maximum for zero point 0.4. So we should take a cut point at zero point 0.4 for the probability that above this point we should declare a class positive, and if the probability is less than 0.4, then we need to declare the probability as the class value as 0. That it means that the person has no disease. So you can find all these things just writing in this measure command. We have score. Score is basically the predictor, and this is the predictant. For example, if you are conducting a test and you have the actual values and you have the tested value, so you can compare the tested value with the actual value. then you can see whether the test is predicting the outcome correctly or not. And similarly, if we have a biomarker, then we can determine on the basis of the value of the biomarker, we determine the actual outcome of the disease. So when the biomarker is continuous, then we need to decide a threshold value or a cut point on which, on the basis of that cut point, we declare the class as positive or negative. That's all about the uh, cut point estimation. And now we will find that ROC curve for the, for example, we are taking cholesterol level as the predictor, and we find in the heart disease status. Basically, the patient has heart disease or not in terms of 1-0, and this is cholesterol level in on a continuous scale. So we just find that ROC curve between these two variables, a marker and the outcome. You can just see the class of the ROC, that is ROICT, and you can see number of positive values, number of negative values, and the area under the curve, that is 0.4232. That is worst predicting the outcome. Basically, cholesterol level alone is not a good predictor of the heart disease. Uh, Below zero point 0.5 is the worst case. Zero point 0.5 is basically just a random guess. So zero point 0.4 is not acceptable at all. But we are just for illustration purpose, I am using this value. So basically we are checking cholesterol level is predicting the heart disease status. And we can see the names. These are the variables under the ROC. These are the objects. We can find the positive counts, negative counts. These are the positive counts and negative counts. And positive D and negative D distributions, and then area under the curve and the cut off and the true positive rate. So we can find all these things. Then if you want to find positive counts, you can just write this, that is 5 to 6. Number of negative responses, you can see the number of negative responses. And then we can combine, we can see all these in one data frame using cbind command, and just see the head means first few values of the cutoff and true positive and false positive. These are the value cutoff values for the cholesterol level, and these are the true positive rate and false positive rate. So true positive rate is very low for this threshold, and some a little higher for this threshold, and these are different values. And these are the last values. Uh, we can see for this threshold, for threshold 126, we are getting true positive rate 1 and false positive rate also 1. So this is basically the last corner of the ROC curve. Basically, ROC curve plots from here to here, starting from 0, 0, then 1, 1, and we need to decide the area under this curve. You can just see plot and just plotting. So this is the area under the curve. So 45-degree line is the worst one. When we are doing a random guess, the curve will be plotted with this. Just we are randomly predicting the values, but the curve we get is worse than the random guessed. And this is the area under this curve, that is 45%. 44%, I think. And you can find using this C confidence interval for the area under the curve. That is important. You need to report in different articles when you are interested in finding the area under the curve, ROC, uh, and then area under the curve. Then you need to show the confidence interval as well, and you can find this. This is the 95% confidence interval that is starting from 0.38 to 0.45. Uh, for the area under the curve. And this is the same command I have just repeated, I think. And you can see we can run a we can find a ROC curve using the binomial distribution fitting. Basically, we are predicting probabilities based on binomial distribution, and you can just run how this ROC curve looks like, and you can see the values, different values for the ROC curve for 10 using the binomial distribution. And this is the non-parametric version. You can use non-parametric using method is equal to none. If you don't write the method, it means it will calculate the empirical based on data. And if you write the binomial, then it will predict the value using a binomial model. And if you write none, it means it will calculate using non-parametric approach. And you can see the summary for ROC binomial. It's taking time, and you have slightly higher area under the curve, that is 0.556. And under non-parametric, you are getting same result almost when using the empirical method. And you can use the DeLong method to compare the difference between AUC value and their different AUC values and their standard errors. For example, if you have two ROC values, then you can compare you can use the uh, DeLong test, compare the values, and it will provide the confidence interval is we are getting basically using the DeLong test. So this is the confidence interval we already obtained. This is confidence interval for the area under the curve. And you can also find the area under the curve using a bootstrap method. That is another method. I just check the result. What is the difference between the two results? Uh, this is obtained for basically this is we are getting for the binomial model, binomial ROC, and this is we got for uh, bootstrap ROC. So these for non-parametric one. So these two values are not comparable. If you want to compare, you can just write NOC ROC non-parametric. Here you will get the same result with a little difference. And then confidence interval for the ROC curve, we can this is the confidence interval for the area under the curve, and you can find the confidence interval for overall this line. You will get a line lower confidence interval and upper confidence interval for all threshold values. So let's check. You can just write confidence interval ROC, CI, ROC, and then ROC you have already established ROC1, that is the empirical ROC, and you can get the confidence interval. And you can plot this confidence interval. This is plotted on one below and one above. These are the two confidence intervals. And you can find the control for the binomial model as well. And you can add the lines with true positive rate and false positive rate for the binomial model. Just check how you can find. So first we need to run this control for the binomial ROC, and then you can add the lines to this graph. Here is the line that is plotted for true positive rate and false positive rate, and then second plot, these are the lower confidence interval, a lower true positive rate and ROC value versus ROC value. So you will get a second line. This is for lower true positive rate, and this is actual true positive rate. And you can run the upper true positive rate that will show a upper limit with this. Sorry, this is not working. So you need to change. I think this is written as this, and this should be just binomial, not 99%. We are writing for 95% confidence interval. So these are lower and upper confidence interval for the true positive rate. And then you can add legend to this graph using legend command. This is empirical ROC. This is empirical ROC, and this is for binomial ROC. And you will get a legend in this corner, basically on bottom right corner. That is this place. So this is the graph you need to present in your analysis. And basically the area under the curve is the most important thing, which is obtained by plotting the false positive rate versus true positive rate. And the area below the line is basically we need, that is a measure of evaluation performance of the diagnostic test. If a test well diagnosed the outcome, then we will get a larger area under the curve, something like this. So this is just an illustration of computing the ROC and finding the AUC and plotting ROC, and then finding the cut point. Basically, the cut point, obtaining a cut point is more important. You can find a cut point for the cholesterol level using the command of cut point. I just skipped this, although we found the cut point for the probability. You can just use this measurement command. Also, although you can use the ROC command as well, but you can find with this command the cut point. So that's all about if you just want to find the cut point for the cholesterol level. How you will find, you can just find the this command cut off from ROC cut off, just from the ROC1. You can just find, for example, you will get different cut points. Then you need to decide a cut point where the true positive is maximum. So you can just do that by observing this curve, or you will find all the possible values that are plotted on this line, and you can see what is the maximum value of the AUC, and that will be your cut point. Although you can also find the a cut point based on UDAN index. You can see how you can find UDAN index, that is just sensitivity plus specificity minus 1. You can add another column just using the sensitivity and specificity. And then based on the UDAN index, you can decide what is the cut point for cholesterol level. So that's all about finding the evaluating the diagnostic performance of diagnostic test. Thank you for watching. And if you have any question, you can always write in comment box. Whenever I have time, I